Welcome to our lesson on operations on sets. These are the union and the intersection. In this lesson, you are expected to describe and define the union of sets, the intersection of sets, and perform those set operations. Use Venn diagram to represent the union and the intersection of sets. So we have here two sets, set A and set B. What are the elements that are in set A? How many elements are there? What are the elements in set B? And how many elements are there in set B? So I have here another question. If I have here three choices, set 1, set 2, and set 3, which of the following of these sets shows the union of set A and B, and how many elements are there? Let's answer that. So it says here that set 2 shows the union of set A and B because it contains all the elements in A and all the elements in B. So as you can see, the elements here, the 6 elements, are found in set 2, and all the 5 elements of set B can be found also in set 2. But there are only 8 elements. Since the star, heart, and the cross are already here, we don't need to rewrite that or draw that again. So if we have this illustration, can you define what the union of sets is? Now let's have another question. Which of the following shows the intersection of set A and set B? How many elements are there? So you have here two choices, the set 1 and set 3, since set 2 is already the union of set. So let's have the answer. It says here that set 3 shows the intersection of set A and set B because it contains the elements that are in both A and B. And there are 3 elements. So what are those elements that can be found in A and also can be found in B? So we have here the cross here. So let's check if we have the cross both in A and in B. Yes. We have the star here. Is it in A and in B? Yes. We have the heart here. So it is also in A and in B. So there are only 3 elements in the intersection of set A and set B. So if we have this illustration for the intersection of set, can you define what the intersection of set is? So let's have this definition, the union of sets. If we have two sets, A and B, the union of sets A and B denoted by this notation, we have here the union as U is the set that contains those elements that are either in A or in B or both. So an element X belongs to the union of sets A and B if and only if X belongs to A or X belongs to B. So writing that in set builder notation, we have the union of set A and B contains X such that X is an element of A or X is an element of B. And illustrating that with our Venn diagram, we have here set A and set B. They are shaded regions, so it means that the union of set A and set B. So now let's have the definition for the intersection of sets. So the intersection of sets A and B denoted by this symbol, the inverted U. It is the set containing those elements in both A and in B. So an element X belongs to the intersection of set A and B if and only if X belongs to A and X also belongs to B. So let's write that using the set builder notation. So the intersection of set A and B contains X such that X is an element of A and X is also an element of B. showing that with our Venn diagram. So you can see here the shaded region. This is the intersection of sets A and B. So the intersection is the overlapping part of the two sets. So it means that all the elements in A that are also found in B. So the cardinality of the union of sets has this equation. The cardinality of the union of A and B is equal to the cardinality of A plus the cardinality of B minus the cardinality of the intersection of A and B. Let's have this special set, a disjoint set. We can say that set is or sets are disjoint if their intersection is an empty set, or meaning they don't have any elements in common. So the Venn diagram shows here. So they are not overlapping. They are disjoint sets. So let us have this example. A set A containing 1, 2, and 3, and B containing 3, 4, 5, and 6. So what are the elements found in the union of set A and B? How many elements are there? What are the elements found in the intersection of A and B? And how many are there? So this is the answer. If we have here the elements 1, 2, 3 in A, so we can see here this is our set A. So we can find 1, 2, and 3 inside A. And if we have set B containing 3, 4, 5, and 6, so we have this yellow circle here. So we have here 3, 4, 5, and 6. So answering the question number 1, the union of A and B, it means all the elements found in A and in B. So all of their elements. So we have the 1, 2, 3, 4, 5, and 6. So we have 1, 2, 3 here. This is set A. 3, 4, 5, and 6. This is our set B. So the cardinality of the union of set A and B is 6, since there are only 6 members of the set, or 6 elements. How about the intersection? What are the elements in the intersection? So from the previous illustration, we have the overlapping part as our intersection. So this is the overlapping part, and the only element found in this portion is the number 3. So we have here the member of the intersection of A and B. So how many elements are there? Only one element, because that is the only element that are common to A and in B. So we have here, you can see here, 3. We have here 3 and here. So the number 3 here is the only common element of A and B. And if we are to use the formula for the union, for the cardinality of the union of sets A and B, we can have this equation. So since the cardinality of A is 3, because there are 3 elements in A, plus 4, the elements of B, minus 1, y1, because there are only one common element, or the element in the intersection is 1. So we can solve for the cardinality of the union of sets A and B. So we have 3 plus 4, 7, minus 1, that is 6. So same with this equation. Now you have to answer this quiz. Given here is the Venn diagram of two sets. So we have set M and set G. And this is your assignment for today. Please copy this in your notebooks. So this is our lesson for today, and we will discuss another set operation next meeting. Thank you.